In this video, I will talk about the theory of relativity. Relativity, you may have heard of the word in a movie or in a classroom, but to actually understand what it is special. Maybe that's why it's called special relativity. To explain the concept, there is a speed at which one object or reference frame moves to another comparable to the speed of light, being 3 times 10 to the 8th power meters per second. It wouldn't be until later when general relativity was discovered by Einstein, which involves space, time, and mass like special relativity, but gravity as well, which is the difference. General relativity affects on inertial reference point or frame and accounts for gravity on light. Here we have two observers. Observer 1 standing on the side looking at the train as it passes, and observer 2 who is sitting on the train facing forward. When the middle point of the train passes observer 1, 2 lightning bolts hit the train, one being in the front and one in the back. The flashes hit the train at the same time. According to observer 1 who is standing, but observer 2 sees it differently. He's facing forward in the train and sees the front bolt hit the train first and then notices the back flash from the other bolt. Who is correct in this situation? Well, according to Einstein, the light from both flashes hit the middle point of the train at the same time, being the speed of light. Both observers are correct because of their frame of reference in which they saw the flashes happen. In conclusion, from different reference frames, there can never be an agreement to this event. This is an example of special relativity. Two terms that are important when we think of special relativity are length contraction and time dilation. Time dilation in its most basic form is the idea that as you move through space, time itself is measured differently for a moving object than an unmoving object. An object's motion close to the speed of light allows a way to travel into the future faster than we normally do, and when this happens, the object can appear shorter or contract in the direction of its motion when observed by someone at rest. This is known as length contraction. Thinking about a GPS like the one you use on your phone and thinking about Einstein's theory being general relativity, a clock will run at a slower rate under a greater force, gravity being that force. So a clock on Earth observed from a satellite orbiting in space will tick slower. This idea is very important when it comes to making fine adjustments that are needed for a GPS, because the small differences in time can compound fast, which can give a false position. The clocks in space run faster, gaining about 45 microseconds per day compared to the one on your phone. This is because of time dilation, but overall relativity. General relativity shares a connection with gravity that was discovered. This revolutionized our understanding and unlocked new thinking. Space-time. Einstein believed that space and time are basically the same thing. They're linked. Space-time then is curved by mass and energy. The curvature this creates disrupts objects' path through space-time. Objects being planets and stars don't move in straight lines. Geodesics is used to describe this path, which is equal to straight lines in space-time. Gravity can be thought as the effect of curvature of the spectrum. General relativity can be used to describe many things like gravity, but also things like the behavior of a black hole and the expansion of our universe. In conclusion, the theory of relativity is revolutionary. It improved the way people thought, and it was a gateway to understanding the universe. Einstein discovered new concepts of space, time, and the very essence of relativity. From time dilation and length contraction to gravity, relativity has changed the way humans think and perceive the world. Einstein once quoted, when forced to summarize the general theory of relativity in one sentence, time, space, and gravitation have no separate existence from matter. My name is Michael Justice, and thank you for watching.